Pages 14 and 15. Start with the least common multiple. Sometimes we abbreviate that LCM. The least common multiple of a set of numbers is the smallest number that's a multiple of every number in the set. So 6 and 9, the smallest one that's a multiple of both is 18. 6 goes into 18, 9 goes into 18, and there's nothing smaller that works. The least common multiple of 5, 6, and 9. Feel free to pause this and think about it. You could find the least common multiple of 5 and 6, and then look to see if 9 goes into that. 5 and 6 are relatively prime. We just have to multiply those, we get 30. Does 9 go into 30? Well, no, but it almost does. 3 goes in at least. So we'll bump that up by 3, we get 90. 90 is the smallest number that 5, 6, and 9 all go into. Smallest positive number. If numbers in a set of numbers share no common factors other than 1, the numbers are relatively prime to each other. So 5 and 8 as a pair are relatively prime, or as a set, we could say. They're relatively prime, even though 8 is composite. Numbers don't have to both be prime, they just have to share no common factors. So as a set, 5 and 8 are relatively prime, because 1 is the largest number that goes into both of those numbers. 2 and 8 as a set are not relatively prime, because 2 goes into 2 and 2 goes into 8. So we can't say 8 is relatively prime. We have to say the set of numbers consisting of 2 and 8 or 5 and 8. And numbers can only be relatively prime with respect to each other. It's another way of saying what I just said. If two numbers are relatively prime, their LCM is just their product. Just multiply them together. So like 5 and 6, and you're done. To find the least common multiple, here's what you do. To find I write it out, I just write LCM of two numbers. We're going to start by drawing an upside down division sign. So just like we did the division earlier to find the prime factorization, we're going to do something similar, but now we have two numbers inside. Finding the least common multiple of two numbers. We're going to take the largest number that you notice divides both numbers inside. Write it to the left of the division sign. If that largest number is 1, numbers are relatively prime. So the LCM is their product, and multiply those two numbers and you're done. Otherwise, continue the process. Divide, drop the quotients down below the numbers. We're going to just keep doing that, steps 2 and 3, until the largest number to go into both numbers is 1. And then the LCM is just the product. We just multiply together all the numbers along the left and the two numbers at the bottom. Let's get an example. So if I want to find the least common multiple of 9 and 12, I'm going to say, what's the largest number that goes into both 9 and 12? Well, it's 3. So I'll take out 3. 3 goes into 9 3 times. 3 goes into 12 4 times. I'm going to multiply these three numbers. LCM is 3 times 3 times 4, which is 36. Let's do another example. So we've got our first example. Move on to page 15 and start in on examples here. I'm going to look at 36 and 90. If you're feeling pretty confident, go ahead and pause the video and start on that. Notice that there are a number of ways that we can start this out. Doesn't matter if I take out the largest thing that goes in there or just the largest thing that I happen to notice. Maybe I just see, oh yeah, they're both even. Take out a 2. 2 goes into 36 18 times and into 90 45 times. And then I say, oh wait, those are multiples of 9. Let's take that out. 9 into 18 twice, goes into 45 5 times. 2 and 5 are relatively prime. Once we have numbers that are relatively prime, we can figure out the LCM. In this case, we have 4 numbers to multiply together. 2 times 9 times 2 times 5. 2 times 9 is 18, 2 times 5 is 10. Multiply those together, we get 180 as our LCM. Example 2, we'll have 24 and 48. Something a little interesting happens here. And the reason it happens is because you might notice that 24 goes into 48 evenly. So your answer, however you do it, should be, give you a hint, it's one of those numbers. Think about which one it has to be. Now on number 1, you'll notice I took out a 2 and then a 9. Let's backtrack to that. What if instead I had taken out, so I'm going to call this example 1 part 2. What if instead I had taken out a 9 first, or let's say a 3. Take out a 3. 3 into 36 12 times, goes into 90 30 times. Maybe now I'll take out a 6. 6 goes into 12 twice, goes into 35 times. Turns out 3 times 6 times 2 times 5 is 180. We get the same answer. Doesn't matter if we pull out a 2 and then a 9, or a 3 and then a 6, or an 18, or a 3 and then a 2 and then a 3. However we do it, we should get the same answer. Example 3. Let's take a look at 64 and 96. Again, you can do that now by pausing the video, or at a later time. Example 4, 24 and 60. And example 5, let's look at 15 and 8. Go ahead, take some time on those, and then we'll meet up in the next video.